Hey guys, welcome back to Math 8. I hope everybody had a great spring break. I guess until I figure out a better way to do things, that this is how we will do them. I will give a few notes, and then there'll be an assignment associated with those notes. You can print the notes off on my Schoology page, as well as the assignment that goes with them. Today we'll be doing the notes for section 11.4. We're going to kind of pick up where we left off in class, although I will start today by reviewing a little bit about what we did before we left off. So, try not to make this too long. Let's get started. Alright, so before we left off, we were in this chapter dealing with side lengths of a triangle. You might remember we started with a right triangle, and we learned how to use the Pythagorean theorem to find a missing side by doing legs squared plus legs squared equals hypotenuse squared. And we did that for a few days. Excuse me. And then the last thing we did before we left is we talked about angle measures. And we went over these three big rules dealing with angle measures. The first one was the triangle sum theorem, that the three angles in a triangle always add up to 180 degrees. So, for instance, if we had this particular triangle, we could find the missing angle by setting up an equation where we add the three angles together, and they add up to 180 degrees. The second rule we went over was two angles that form a line. This was probably the most difficult for us to get used to, was when we have a line and it is split into these two angles, that the two angles will add up to 180 degrees. Those two angles are called a linear pair because they are a pair of angles that form a line. And so if we had this diagram, we could solve for x by taking the first angle plus the second angle and adding them together, and that would equal 180 degrees. And then last up was the easiest one probably, is when two lines cross, the angles that are on opposite sides of each other are called vertical angles, and they are always equal to each other. So in this diagram, 5x would equal 3x plus 10, and we could solve for x and the angle if we wanted to. So those are the three rules that we've already gone over, and today we're going to look at a new situation, or I would call this new vocabulary. This is what happens when parallel lines, or any two lines, they don't have to be parallel, but primarily we deal with parallel lines, crossed by a third line. And you can see in the diagram that this creates a bunch of angles. So when two lines are crossed by a third line, that third line is called a transversal. And I'm going to name these lines. I will name the two lines here A and B. And this little symbol right here tells you that those lines are parallel to each other. So when lines are parallel to each other, it's often indicated with little arrowheads, like I just showed you. In the diagram at the right, the parallel lines would be lines A and B, and we need a name for the transversal. We will call it line M. So the transversal would be line M in this case. And as you can see, there are 8 angles formed when you have these two lines crossed by a transversal. And we are simply going to look at pairs of angles and special names for those pairs. And so the first one we're going to look at is corresponding angles. So corresponding angles, let me move up a little bit here. So corresponding angles lie in the same corresponding position, which is why they're called corresponding angle. And what that means is they are both above or below the two lines, and they're on the same side of the transversal. You can see I have darkened in angle D and angle M because they both sit above their two lines and to the right of their transversal, so they are corresponding angles. There are actually four pairs of corresponding angles in this diagram. D and M are one of the four pairs. Can you name the other three? If you want, you could stop the video and try to name them, then come back. They are also C and H. They are both to the left of the transversal and above their line. We have F and K. They are both below their line and to the left of the transversal. And then last up we have G and N. They are to the right of the transversal and below. So the point is there are four pairs of corresponding angles. Now what is special about these corresponding angles is when the lines are parallel, and you'll notice that in my diagram the lines are not parallel, but when the lines are parallel, the corresponding angles are congruent. Do you remember the symbol for congruent? Is an equal sign with a little similar sign above it. Congruent means that they would have equal measure. Now in this diagram they do not have equal measure because the two lines are not parallel. But if you look back here, a pair of corresponding angles might be angle 1 and angle 6, and they would be equal in measure because they are between parallel lines. All right. Mostly today we want to recognize or see if you can recognize when angles are corresponding angles, and then maybe use the fact that they're equal. Let's go to the back. Our next pair of angles are called alternate interior angles. Now they're called interior because they are inside the two lines. They are called alternate, I guess I could have done that, because they are on opposite sides of the transversal. So again, you can see I've darkened in one of the pairs. One of the pairs would be F and M. Those are the ones that are darkened in. But there is a second pair. That would be G and H. These two angles would also be alternate interior angles because they are on opposite sides of the transversal and they are inside the two lines. And again, when the lines are parallel, and these two lines in my diagram are not parallel, but when the lines are parallel, the alternate interior angles are congruent. So that's our second pair. We have corresponding angles, and we have alternate interior angles. And the last one you can see are called same-side interior angles. That would be a pair of angles that are on the same side of the transversal, and because they're interior, they are inside the parallel lines. These two would be G and M. That is the pair that is darkened in. Notice they are inside the two lines, meaning in between the two lines, and they are on the same side of the transversal. So same side, interior, inside the two lines. And the other pair would be F and H. They would be on the same side of the transversal and inside. the two lines. And these two angles also have a relationship, but they're not congruent. When the lines are parallel, and only when the lines are parallel, these two are said to be supplementary, which means they add up to 180 degrees. All right, so there's your kind of three vocabulary words. I'm going to do a few examples with you, and then let you try your homework. So here's the first set of examples. You are supposed to classify each of the following pairs as either being corresponding, which we will just use a CA for corresponding angles, alternate interior, which we will call AIA, alternate interior angles, or same side interior angles, SSI. Now, I've also included here, I see, a straight angle, which I don't really like called a straight angle. I don't think it's as good as a linear pair, but it means the same thing. Two angles that form a line are a straight angle or a linear pair. So I will do the first one. And the first one, this angle A and angle B, they are a linear pair. I will call it LP. If you want to stop the video and try to do the other 7, you can, or you can just watch as I do them. In the next one, A and B are on the same side of the transversal, and they're both above their line. These are corresponding angles. In the next one, the A and B are both inside, so they're both interior, and they're on opposite sides, so they're alternate interior angles. This next one, they are not corresponding because they're not both above their line or below their line. They're not alternate because they're not on opposite sides, and they're not interior, so I guess this is none of these. The next one, let's see. They're on alternate sides, but they're not interior, so I guess that would also be none of these. This one, we have one interior and one exterior, or outside. We're on the same side of the transversal. They're both below their line. These are corresponding angles. Both of them are below their line, and they're both on the same side of the transversal. That means corresponding. These are both interior angles in the next one. And if they're both interior, they're either going to be same side interior or alternate interior. And these would be alternate interior because they're on opposite sides of the transversal. And last up, again, they are both interior angles, so they're going to be something interior. They're on the same side of the transversal, so same side interior angles. All right, so that section is just can you recognize? And our last section is can you use their relationship to solve? And I will tell you how I would do this. I would say that C plus 123 equals 180 because they make a linear pair. So that means that C equals 57. Then I would say B plus 57 equals 180 because those two are same side interior. So that means B must equal 123. I also could have gotten B by saying that these two are alternate interior angles, so they're equal. And last up, A equals B because they are vertical angles. So therefore, A would also be 123. In the next diagram, I guess the first thing I see is I can get F. F and 82 are a linear pair. So F plus 82 equals 180 because they make a linear pair. Therefore, F must be 98. And now I see I can get E because E equals F because they are alternate interior angles. So E would also equal 98. And then last, E equals D because they are vertical angles. So D would also be 98. And then last up, this looks like an easy one. How am I going to figure out what angle G is? Well, I claim that G would equal 75 because they are alternate interior angles, so they are equal, these two angles. So I guess I'm done. All right, good luck.